Good evening. Tonight, the second private commercial lunar liner successfully touched down on the moon's south pole, but it may be having problems. SpaceX launched another Starship 8 this evening. We'll update you on that. And finally, you will meet the winner of February's $1,000 microgrant. These things and more coming up. From the news desk at the Center for Space Commerce and Finance, my name is Thomas Andrew Olson, and this is The Unknown Quantity. Okay, as always, we raise the question, who are we? What are we doing here? Why are we here? Why are you here? What is the Center for Space Commerce and Finance? Well, we're a 501c3 nonprofit organization dedicated to championing and strengthening emerging space startups, space scalable, small and medium businesses, space adjacent enterprises worldwide through advisory access and advocacy across the funding spectrum. Our programs fortify business plans and investor readiness for founding teams at varying levels of development. Of course, one of our latest initiatives is our monthly space microgrants, where we award $1,000 each month, no strings attached, to an aspiring startup. To apply there, you go to spacemicrofund.com, and the form is right there, and it's easy to submit. We also encourage our listeners and fans to help support microgrants. Near the bottom is a link button to our support page where you can get the option of a one-time gift or a monthly subscription. Now, $50, $100 a month, not a lot, for 6 months or more, helps a lot of new firms get out of the garage. So joining me now is one of my favorite podcast producers, entrepreneur, one of my oldest space friends, Michael Lane from Liftport. Michael, come on in, man.
Hey,
how you be?
I'm good. How are you?
I'm not too bad. I went to the gym today. I just worked my ass off, and I think I puked once. But it's what you got to do. At my advanced age, you have to do things. If you're not doing anabolism, you're doing catabolism, and then that's the end of it. So I keep it up.
Right on. Well, glad to see you doing well. It's kind of a sunny day in Seattle. We haven't had one of those for a little while, so it's a nice change.
It was beautiful here in Central Florida. Wasn't as beautiful for a couple of spacecraft and launch companies today. As I said earlier, the Intuitive Machines Athena lander, they made it to the lunar South Pole. They somehow landed on the lunar South Pole, and then apparently, as best they can know, it fell over. This is a long, tall, skinny thing because it's supposed to hop. You're supposed to be able to fryer that and go and hop around and do things. And so that's why it was built. But apparently, it's a little unstable. They're having problems sticking the landing. But it's in the right place. They made it to the right place. That's kind of how SpaceX is talking tonight too. So.
Well, isn't this the same one that fell over last time? Like, I don't want to beat these folks up because I'm definitely a fan.
Oh, of course.
Was it? Gosh, there's so many systems going to the moon these days. Was it Japan that fell over a couple months ago? Was it also Intuitive Machines?
I think it was in Athena. It's also Intuitive Machines.
Okay, all right.
And so they launched a new one, and now it fell over. It sounds like the swamp sequence from Monty Python and the Holy Grail. Mm-hmm. First I built a castle, then it sank into the swamp. Well, I built another one. It sank into the swamp. I built a third one. It burned up, fell down, then sank into the swamp. Right. But the fourth one stayed up. So that's what we're hoping with Athena. The fourth time will be the charm for them, and they'll have a working thing. I'm rooting for them all the way, but that's got to be, despite our laughter, there's got to be a heartbreaking day for this.
Absolutely, right? Absolutely. This stuff is it's definitely tricky. We're here to talk about the money of space, not the engineering challenges, although they do kind of tend to go
it's
hand in hand.
The coin. These are commercial landers. That's why we're even talking about it.
Right. Right. Intuitive Machines stock tumbles down 20%. And this is going, nationwide, worldwide. That's a hard graph to follow, right? That is, that is not a good day.
So they better have a really good statement to make, and to help the stock a little bit.
Right.
I didn't know they'd gone public.
Yeah, no.
Here they are. That's
no,
never
so their statement, I mean, this piece right here, as the market reacts, all eyes will be on the forthcoming press conference. I have not heard that there was a press conference yet. So here it is, 5:00 on the West Coast. I don't think they issued anything, not that I'm aware of. So
okay.
That's not good. That's not good for them.
Now, SpaceX, by contrast, just when they just turned off the signal when they, because I thought, isn't there supposed to be a launch today? And so I'm getting ready to do the show, and I turn on SpaceX Westbound, and there it is, and it's 1:30 to go. Was I lucky? I watched it live.
Right.
I got some screenshots, and they stuck the booster capture. That's the third time they've done that, and that was cool. That's always cool to watch.
Yeah.
You'll never get over that. You never get accustomed to it. It's always like, oh, that's a big wow moment, right? And then, but then, and it looked like it was the upper stage having a nice smooth ride. It got up to about 135 kilometers altitude and going over 18,000 clicks an hour, and then all of a sudden you could see they had that little icon at the bottom of the screen. And so you see the thing almost horizontal, kind of flying. All of a sudden, it just kind of flipped the other way, and then turned a little bit, vertical, and then flipped back again, and flipped all the way around. They lost complete attitude control, and they started losing communication data, telemetry communications with it. And finally, about 6:40 this evening Eastern, they finally just called a lid to it. Says, we've lost communication with it. If we have any other things, we'll post it on the website. But this live feed is done. Click. And so I guess we'll have to find out tomorrow when they pick up the pieces. But they said that they said, ironically, they're getting better at this. We're getting better at having these failures up there so we can make sure we don't hurt anybody when it comes tumbling back in again. And so they beefed up a lot of their systems closer to the ground to make sure everybody can get advance warning and stay out the way.
Yeah, it's kind of crazy. Debris coming down and hitting stuff in the Caribbean. That can't be good. That is not good for their PR team. They're gonna have to work on that. On Monday's, on Tuesday's show, we showed that clip with SpaceX, and it was a big rah-rah, clip, and it was a great clip. They talk about, well, it's been a month since our last launch, and we're trying to get this down to hours.
Yeah,
that's great. We all want that to happen. We really do. Yeah. But days like today remind us that it is a long ways to go. We're not there. This goes back to what you were talking about.
It's going to be more than hours on this time, this turnaround. Yeah. It's going to be more than hours.
Yeah.
Whatever went wrong with the upper stage, they got to do something about that. It seemed like they nailed the lower stage. Everything worked perfectly. It just was absolutely flawless, all the way up and all the way back down again. So that was cool.
I'll share just a little bit. This is from your screen captures.
Yeah.
I mean, it still looks pretty awesome. I mean, you can't argue that it's a pretty beast. I appreciate you saying these to me. I think they're terrific images.
You see that thing going past the screen, you're like, yeah, and there we go. Yeah. I always love those views. That view from
Yeah. So Yeah, we'll get there. It's not maybe not today, but we'll get there.
But we'll get it. We'll get it. Another interesting thing that just crossed my desk this morning.
Mhm.
One of my favorite stories of all time has to be Voyager 1 and 2.
Oh yeah,
They are both out in interstellar space now.
right.
And they're trying to keep the systems alive to communicate as long as humanly possible. And so they had a bunch of instruments. Of course, when they first went out there, they have this nuclear react. It's not a reactor, sort of. It's one of those highly radioactive sources. It degenerates over time, and doing that, it produces heat, and that produces the power. It's like a thermocouple kind of thing. Well, that thing's been flying now for nearly half a century, and
Years.
it's still working. But they're slowly. The story I got today was there were certain science instruments that decided, well, we're going to turn those off now, because right now that the power is going down, and the rate of loss is something like 5 watts a year or something. It's to trying to stretch out the lifespan of it, but you're losing 5 watts a year or 5 watts a month. I think it was a year, but every year you're losing a little, you're losing a little, you're losing a little,
Gradually losing 4 watts per year. Yeah,
yeah, it's 4 watts a year. So you turn things off because power is all about the draw. What are you drawing? And so that puts the pressure on the system. So they're trying to take a lot more things off, except the bare minimum navigational instrument, so they can move the antenna so they can continue to talk to it and see what's going on. I'm sure they'll run into that Klingon vessel sooner or later, but you gotta keep it moving so it can do that.
Right.
Yes, we always ask about that. We always ask, "Oh yeah, such a beautiful universe. We're going to go out and explore it." We don't know when the frontier is going to start pushing back.
Nope.
There's a whole Star Trek movie dedicated to that notion. It was great.
V'ger. Does everybody remember V'ger? Yep.
Exactly. Too. Yes, absolutely.
Yep.
That's the first one, but the latest one they did also had that theme.
Yeah. Yeah. So that's a remarkable machine. Nearly 50 years old, 48 years old, and still doing its thing, man. I'm pretty surprised, pretty impressed by that. So
yeah. What do you have? I know a couple of things you want to talk about.
Just briefly, we talked about, I don't know, 3 weeks ago about rocketry kind of coming up against a hard limit of there aren't enough spaceports. No one really saw that problem coming, right?
Well, they didn't see it coming in the way they thought would happen. Right. Remember, because we talked about this, it was like most of the spaceports were being built out were presuming horizontal launch and landing.
Right. Yeah.
But right now, 90% of it's vertical.
Yeah.
They don't plan for that.
So they're going to have to build a different way. And so this was kind of interesting. I'm not trying to make a big deal of it, but this quote here. I just had it a moment ago. Well, dang it. I lost the quote, but the basic idea is the only way to. Here we go. The best way to build a future where we'd have dozens, hundreds, or maybe thousands of spaceports is to build them at sea, says Tom Murata, CEO of the spaceport company. It's very hard to find 1,000 acres on the coast over and over again to build spaceports. It's very easy to build the same ship over and over again. I mean, that's a scalable business model if I ever heard one. I love this kid. I've known him for.
You can build an offshore oil rig platform.
Yeah,
we should be able to do this.
Yeah. So I just thought that was really neat. It kind of goes into the theme of containerization and standards, like we've been talking about on Tuesday, and if we are really going to get to point-to-point suborbital, like we also talked about on Tuesday, not every city can have a spaceport. Not. I mean, where would you put it in Boston? I mean, really, where would you put it?
Look, we can't find. They can't find places to land the A380.
Right. Yeah.
You know, I've been on one of those.
Yeah.
It's the wing has a horizon.
Yeah.
And looking out the window, I see the wing. I'm not seeing all the wing. I'm seeing the horizon.
That's
and then
crazy.
a little tiny tip at the end where that up flip goes. But you don't see that until you're actually in the air. Then all of a sudden the wing kind of straightens out and into its flight configuration. You see the whole wing and it's like huge. But that was so weird on the ground. It's like, woo.
Yeah. So then the other thing is, a quick nod to Dr. Autry. He was our very first guest on the Unknown Quantity. Autry is not unknown, so a little misleading there. He's been a pillar in the space community for more than 10 years now. Mm-hmm. But, his program in University of Central Florida is getting kicked into gear. He's doing great. I love this. The Associate Provost of Space Commercialization rides into work on a skateboard barely within the posted speed limit. He wears a suit, tie, and a determined expression that says he's going somewhere important and you might want to follow him. He's great. There's a pretty interesting story about his skateboard, by the way. He has his own skateboard company. That's a weird aside for a university associate provost. But terrific article, really interesting. They're gearing up and they're gonna do good things. So that program just came online at UCF. And then I don't have a link for it, but concurrently, a space policy program just got built in Georgia Tech. So that's the premier space policy institute in the U.S. is in George Washington University, and Dr. Borowitz is a John Logston's acolyte at George Washington. So you're starting to see more and more schools develop more and more programs. I think this is the 10th really solid program in the country right now of different flavors. So whereas we only had 2 10 years ago, we have 10 now. So
well, we should be talking to them because space business education is what we do.
Yeah.
And so at least maybe we can find an opportunity for guest lecturers, be a guest lecturer or something like that, at least. Yeah. And, take part in this somehow. We were right here.
Yeah.
On the Space Coast. We might as well.
You're literally right next to him.
I'm literally an hour from him. So, yeah.
And then the last. Yeah. I'm telling you, you and Sean and Autry should go out and grab a beer. There's another guy you don't know named Andrew. Same story. The three of y'all should go grab a beer. So, all right. And then the last thing I just want to talk about briefly was, the Lunar Trailblazer mission, another low-cost mission, but it looks like it can't find home either. It can't call home either. So,
boom. Yeah.
Well, we just spent the last 2 minutes talking about how this stuff is challenging. So,
and we're gonna we're gonna get into that conversation some more a little bit about how hard it really can be.
Yeah.
We've got a lot of examples today.
Yeah, I'm gonna close out the news and let's bring in.
Okay, let's start. So today we're going to introduce Cube Inc., or it's QUUB.space. They're the February winner of the $1,000 microgrant. They're a satellite startup looking to change how satellites are built, launched, and operated, and the engineering models they make. They hoped it will be used in classrooms and universities to further space education. Um, and with us is the co-founder and CEO of Cube, which is Joe Latrell, someone we both know. Joe is an inventor and technology developer who has coordinated payloads for launch on the Falcon 9, the New Shepard, and Rocket Lab's Electron. Prior to that, he gained a wide-ranging experience in a variety of technology roles. He launched an early-stage suborbital rocket company. He coded programs for large data sets and developed numerous software packages for the education industry. He founded Cube to manufacture small, cost-effective satellites designed to gather data and monitor Earth, its weather systems, and its environmental resources. His goal is to create a network of satellites that give first responders, companies, and municipalities the data they need to respond and act quickly. Joe, congratulations. Welcome to the program.
Oh, thank you, gentlemen. I appreciate everything you've done here. I mean, the microgrant system is amazing, and I'm proud to have been selected. So
Okay,
thank you.
absolutely.
It's a great program.
You're very welcome. So let me ask you right up front, since I'm used to doing boot camps for startups, my favorite thing to do is to try to ask them, challenging questions. And one of them is, you're making satellites. There's a lot of people out there also making satellites and making similar claims. I know Esper Satellite Imagery just got another $5 million grant, and they were one of our contestants, about 3 years ago. So I always like to hold people up as poster children for what we do, as I like to do with you guys. So explain to me what makes what you're building so unique and different and above the pack.
Well, what we've done is containerized a few things. Your Tuesday episode, you were talking about containers, TCUs, and that sort of thing. And space is starting to head that same way. Now, it started with the CubeSat, which everybody knows. I have one of those that's about this big, 4 inches. We like to use metric, so it's 100 millimeters on a side. But there's another standard that was also created by Bob Twiggs, and that was the pocket cube. He says, well, I want a satellite you can put in your pocket. And so he decided, well, let's cut the numbers in half. Okay, so 50 millimeters or 2 inches on a side. And when you do that, you end up with a satellite about this big.
Can you just leave that up for a second?
So that's our
I want folks to see, really be able to zoom in on that. That is amazing.
Yep. Now this is our reference square. This was the first satellite design we ever did. Brilliant. And what sets us apart from other satellite manufacturers is this is 3D printed.
Okay.
Everything of the structure is 3D printed rather than machined out of aluminum or steel or titanium or whatever you want to use. The advantage to that is with 3D printing, I can iterate designs quickly. Okay. We've been known to iterate a design change 6 times in a day.
Wow.
It's like, we think that this can work. We're not certain though, let's build it. No, that didn't quite work the way we intended. So we go back, we redesign a little bit, we print, we test, we keep going. So very rapid iteration. And for, today has been a hard day in space, but I don't think people realize just what hard means in space, okay? And you go through a lot of material, you go through a lot of money, you go through a lot of heartache trying to do this. And we've paid our dues too. So it's trying to build something small and light to do something that hasn't been done before. What
are some of the trades, right? So you can iterate quickly. Is it as strong as the aluminum? Does it handle the shake and bake testing as well? Is it structurally in the same ballpark?
Yeah, good questions. Yeah, it is actually very close to aluminum in almost every respect, because a lot of people, when they think of 3D printing, the idea is that the little Creality or Bamboo Labs printers that you can get at home, and they're called FDM. So it's just essentially it's like cake icing, and we're just going to put it one layer at a time. Okay, we're doing the same thing, but we're using a laser to do it. And so we don't have a structural integrity problem along the lines. It's as if it were one grown piece. So yeah, we grow our satellites, we don't manufacture them. And because of that, yeah, we get all the same strength that aluminum has in compression and tension. It's just a fantastic material. So as long as you know what aluminum is going to do, you can use the same material just as a drop-in replacement.
Okay, cool. And then costs.
That's where it really
I thought
shines.
you were going to say that.
Is that usually if you're doing a machining process, you're going to have an operator who has to run that machine. And with 3D printing, you still have an operator, but it's not delicate work all the time. The computer and the printer are doing the delicate work. We just have cleanup. So the cost of manufacture actually goes through the floor. Our satellites are nearly an order of magnitude cheaper than what you could do even a decade ago.
Awesome. All right. So what do you do with these super small satellites you can fit in your pocket? And can you show me? You showed us a couple before we got started here. What's in your toy box there?
Okay, so I showed the Pocket Cube, and this was our first satellite design. Well, you can't do that forever. You need to actually do something useful in space, and there are people using this form factor for useful stuff. We want to do Earth observation, and so that means you have to do a little bit of compromise. And on that, we compromised, and we built a satellite this big. It's what we call a 6P. So just like in CubeSats, where you stack them, 1, 2, 3. Yep. So this is a 6P.
Sorry, I interrupted you. Could you go into that a little bit deeper? Because I know what that means, but not everybody who's listening knows what that means.
Okay. Well, let me grab a CubeSat here real quick. If we were to stack 2 of these CubeSats together, that is now a 2U. So this is a single unit. We put 2 of them together, we get a 2U. We put 3 of them together, we get a 3U. If we now go this direction, you end up with a 6U. Because you got 1 by 3. Now it's 2 by 3. You get 6U. So we do the same thing with the Pocket Cube. And again, I'm just going to stack these together. It's like that's a 2P Pocket Cube.
So instead of U's, you're replacing U's with P's. P is Pocket. Okay, great.
Correct.
Terrific.
Yep. Yeah, but it's 1/8 the volume of a CubeSat. Now, a lot of people have said we can't do anything useful that way, but that was the same thing that was said about CubeSats back in 2004. We're doing the same thing, and because of cell phones, I mean, grab your cell phone. That micro miniaturization is what allows us to build our satellites this small. We're not doing anything super new and unique. We're combining things that already existed and new in different ways.
So, what? Okay,
go ahead. No, go ahead. You had 7 on your mind. I'll come in next.
Well, so that leads to the question of what are people doing with the Pocket Cubes? What are y'all doing? I thought it was really intriguing on your website. The first thing you say is, we're a data company. Yeah, we use data coming from this cool stuff in space, but at the end of the day, we're a data company. So what are people doing with the Pocket Cube form factor first, generally, and then what are you doing?
Well, it's a really popular form factor in Europe right now. As a matter of fact, there have only been a handful of companies even tried Pocket Cubes in the United States. We're still standing. Most of them have gone by the wayside. But it's a university tool. Universities have grabbed this. High schools have grabbed this. Romanian high school teams have actually built these satellites. And what you can do is, simple measurements. I just forgot his name. Right, boom. But out of Hungary, there's a gentleman. He put instruments. He was looking for EM noise, electromagnetic noise, and mapping the Earth with this little Pocket Cube. And it's like, wow, okay, if you can do that in the electromagnetic spectrum, looking at all these cell towers and everything that are bleeding all over, what can we do for the optical side? And I was like, all right, well, let's find out how far we can take the optics and get imagery of Earth. This is not imagery in the sense of we're taking pictures at 30 centimeter resolution. That's not our objective. Our objective is 5 meter per pixel now. Our next generation will be 2 meters per pixel. And that's as far as we're going to take it, because we're not looking at the images, we're looking at the changes. So when we talk about data, it's like, all right, you take a picture today overhead, and then you take a picture tomorrow at the same time, and then you do a difference analysis, and you can see, well, what's changed, right?
Mhm.
Our objective is to move that needle even further forward and reduce that time frame. So ultimately, a 15-minute window per image. And when I say image, what I'm really saying is electromagnetic spectrum from near IR to UV. So we're covering a lot of ground there. And what we're looking for are changes in vegetation, changes in water content. Those change over the hour by hour, those actually change on land. Okay, so if I fly overhead and I do that once a day, but it's not at the exact same time, then I'm not going to get consistent information as to what's happening on the ground at that moment. And that's the objective, is we want to do this. So what's it useful for? Well, you can spot water intrusion events. That's what got this started, by the way. I spent a few years as a water quality engineer. And I think that's just a fancy term for person who crawls around in sewers. It was not a glamorous job, but you see what happens with water and how it can be contaminated very easily, and what the mitigation processes are. It was like, well, if you knew it was coming, you could mitigate and lower the potential problems that you have here in my hometown. Well, like, I live in Lancaster, PA. I dodge Amish buggies going to work. So wrong place for a satellite company, but anyway, yeah, just lost my train of thought. I'm so sorry.
No.
It's been a long day.
So stick with that for a
No
second.
worries.
So you're taking a picture, frequent recycles, repasses over a particular area. How big a constellation do you need in order to do that?
That we would need 400 satellites to achieve what it is we want to do.
Okay.
And now the beauty of that is we're taking a picture every 15 minutes and we're looking at these differences. Well, imagine the data matrix that you get with that. Okay. So you have every day, every 15 minutes, there's an image, but you're doing day after day after day after day. Well, and you were doing 10 discrete spectra. So look at how deep that data goes. It's 4-dimensional data. We're looking at information through time across 2 different vectors.
Okay.
When you do that, now I can look at the land and say, in agriculture, maybe you're irrigating your crops 30 minutes too early or 30 minutes too late.
Wow.
That can be determined because you can see the health of the crops and how they're behaving hour by hour. And that does change.
Yeah.
Okay. With the water quality, you're going to see a temperature change. I hate to break this to everybody, but raw sewage has a huge temperature difference from river water.
Okay.
And maybe I can go into more depth about that with you guys over a frothy beverage, but let's not. Don't want to gross your audience out. But that is a huge temperature gradient. So that's going to show up on near IR.
See it right away.
Right away. And so anybody who's using surface water, we could see things like, all right, the Susquehanna River here, which provides Lancaster all of the bulk of its water, had a intrusion event. A lot of raw sewage got dumped into the river right above our intake lines.
Wow.
Okay. Now, if they had gotten a warning, they could have closed those valves instead of having to shut everything down, shift over to our backup water supply, and then spend tens of thousands of dollars cleaning everything up, getting it back to the levels that it needs to be. They need 3 days of clear testing before they can turn it back on. And the overtime is ridiculous for something like that. Okay. Municipalities don't have budgets like that anymore.
Yeah, that's $100,000 error.
Right.
Maybe more.
So if you had a subscription and your water plant operator gets a text on his phone that says, "We see something unusual upriver from you. You might want to be ready."
Mhm.
That's cool.
That's what we're trying to do.
Okay.
Right? And from there, think about what else you could monitor.
Yep.
How about oil and gas lines? Right now, that's done by drone, and they're depending upon the size of the line, they have so many passes they have to do every day. Well, what if you could do that from space? Now you don't have a crew going out with drones flying them all over the place.
Right.
Or if you see a pressure drop, it's like, oh, well, we were just over there. We took a picture of it. We can tell you, yeah, the ground temperature is changing here. Guess what we think that might be? And now you can dispatch the team straight there instead of flying a drone, finding it, then dispatching the team.
Well, that certainly explains why you talk about being a data company, because that means you've got some sort of AI or algorithms monitoring. And then when there's an exception report, that's when you say. So you did kind of answer the question though. So this is a subscription model based business. For who do you sell to? So you sell to pipelines, gas companies, water treatment. If you're doing stuff in the IR, can you also pick out fires?
Yes.
Fires? Yeah. Okay. All right.
Yeah.
Okay.
And the beauty of IR is it isn't clouded as much by the smoke. All right. It's not like synthetic aperture radar. Synthetic aperture radar goes right through clouds with no problem. But the temperature changes again across that forest can be spotted, and then you can monitor the growth of the fire. How much better control would the Los Angeles fires have had if they had found it 15 minutes after it happened instead of 30 minutes after it happened, or 45 minutes after that?
2,000 degrees in 2 minutes. Yeah, absolutely. That's all you need. I was going to get into your business model a little bit there, because you're a data company. You're selling subscriptions, but you're also making custom hardware. You're selling that to people as well.
Mm-hmm. Yep. I believe in space being accessible by anybody.
Right.
So if you want one of our satellites, you can buy one. You also put whatever you want.
You also mentioned in your materials that you want to take engineering models and make them useful in classrooms and universities and do stuff for space education.
Yep, we have a couple of kits that have been developed. We're actually shipping out the first ones next week to some groups where we want you to be able to build a satellite in class. And right now, those engineering model systems can cost upward of $2,000. Like, okay, there's got to be a better way of doing this. And again, we 3D print the structure. It is not the same thing as our flight hardware. I need to stress this. Do not attempt to fly this to space. It is a teaching tool.
Don't try this at home.
We want you to try this at home. Just, if you need to book a flight, talk to us. We'll get you some
Yeah,
flight
it's the other way around. Try this at home, but nowhere else is the thing. So are you, but you're still more or less pre-revenue, or are you actually getting a little coming in?
Well, we've done a lot of grants, a few SBIRs that we worked with a prime on.
All right.
But yeah, primarily we're pre-revenue. We've got over 12 companies that are interested in the data. Now it's starting to build out that network, and we've got 4 satellites on schedule to launch later this year. So that's our final test before hopefully we are able to raise the money to go full hog, as they say. Our manufacturing techniques are all standardized. So the bus is common. I'm going to give away a little bit of secret sauce here, but it's okay. We use a full-blown computer on board. We're not microcontroller only, which a lot of satellites are. All right. We're a Linux-driven machine. A real-time Linux system is on board. It has a lot of safeguards in it to prevent people from hacking it, because you can't talk to it directly. And it's a traffic cop. Its job is to look at the data and analyze it and get all the sensor information where it needs to be. what that means is we have a standardized bus that we use, USB, to talk to all the microcontrollers.
Mm-hmm.
Right. So it's a Lego.
Yeah, I
We
was just
built a
thinking that
Lego.
everything can just snap into what you need and where you need it.
Mm-hmm.
That's clever.
And we made it so that the CPU doesn't need to know what the sensor is.
Mhm.
Okay, so the microcontroller carries the code that it needs to run. It plugs in, the CPU does the poll. It says, I see you, but I don't know what you are. The microcontroller can then say, I am this, and here's the code to run me. This is the segment of the API that you need to talk to me. And that's it. Now the CPU is already updated and ready to go. So you stack whatever sensors you want. We need a new sensor or something better comes out. We only have to design the sensor module. You snap it in, and now the satellite's upgraded.
Brilliant.
That's
brilliant. If it takes 400 satellites and they're this big, that doesn't take a lot of flight space, cargo space. So that means you can launch almost all 400 all at the same time, or would you stagger them in different fleets? Yeah, sorry. Maybe that's too deep.
Due to orbital mechanics, they can't be all launched at the same time. Okay. So we do have to stagger it out. They are polar orbits, however. So that you can see how that would work. Some of them are sun synchronous, a lot of them are polar, and we're thinking about putting some mid latitudes in there just to catch a few spots that might need a little bit more data. So we're looking at launching a few times, at least, and we've got flights booked with Phantom. We've got flights booked with InnoSpace. We're working with a lot of different companies to the unsung launch companies that are trying to get into this market as well. And they need customers. We need rides. Mm-hmm. I'm willing to take risks because my satellites are so inexpensive.
Yeah. You could lose a batch and kind of have them replaced by next week. I'm not trying to minimize that, but you have got a good model there.
Right. It's not, we're building a $10 million satellite, launching it to space, and then having something go wrong with either the launcher or the satellite bus.
Right.
So one of our listeners just piped in and says, do the satellites communicate with each other, or does it matter?
Yes, they do.
Okay. To what end?
Because the satellites need to be able to see the information to do the analysis. We have essentially a satellite takes the imagery, forwards it back to the satellite that's going to be coming next.
Okay.
And we do it that way. And then when a change happens that crosses the threshold of what our customers want,
I can't do
that gets Siri decided that what I was saying was important. So sorry about that. But yeah, then we can relay the information to a satellite that's passing over a ground station and give it a priority. Just like the hardware is modular, all of our software is modular. So we can change satellite components out for doing the communications between the machines. We are experimenting with laser right now, but it's typically RF.
I was wondering about that, but I didn't think you could pull that together with such a small spacecraft. Never mind.
Yes, you can. Yes, you can.
The short version is yes, you can. Okay.
I withdraw the question, Counselor.
Yeah, and I'm going to give a shout out to a gentleman who is one of our advisors. His name is Lloyd Spanberger. Lloyd worked on the original Corona satellites, the Corona spy satellites. He developed the forward-looking infrared camera for the SR-71 Blackbird.
Oh.
He's built his own lasers. This is a guy who keeps us out of trouble, and his input on laser operations and theory have been invaluable to our company.
Well, that's a guy I'd like to get to know. No, okay. So it's probably been 2 or 3 months ago, but there were some developments in the laser field of space communications, and I'm like, this is the future. We're going to move past radio frequency. It won't support the internet of space. There's too much data, not enough throughput. And to me, the future of space communications is lasers, but in a box like, the size of a walnut, 2 walnuts, let's say it's 2 walnuts wide.
It's pretty.
I couldn't figure out how you could do that. So that seems kind of mythical. I'm damn impressed by that. That's probably the most impressive thing you've said today out of a lot of impressive things.
Yeah, when I say when I said earlier that space is hard, but people don't realize how hard it is, we're basically taking everything that we know, your entire cell phone, with a more advanced space-rated gear, and squishing it down into a little box and making it work. And that is incredibly difficult to do. You have to have you have to have an iron stomach for failure. Let's just put it that way.
Well, the same guy who just asked the first question's got a follow-up, and I want to know the answer too. How do you pick up the laser signal with such a small antenna?
The laser signal, again, this is getting into the physics, and I would say let's talk to Lloyd.
Okay,
because one of the first things that I learned in business was, okay, I know some things,
right,
but there are people who are much smarter than me.
Right.
Hire the smart people. Let them figure it out. So the details,
we'll
drop
pass
us an email, and I can get into the theory of it, but it's rather impressive how it can be done.
So I'm going to put your LinkedIn address in the chat, and so Morty will probably reach out to you after the show.
Okay.
I got I think an important question with a follow up. What are you going to do with the microgrant?
Believe it or not, it has to do with 3D printing. We want to get a new prototyping machine that is multi-material. And that's what we were looking at. It's like, okay, right now, and we are a small shop, and we just don't have the budget to get this printer. And winning the microgrant allows us, that completes the last bit of dollars that we need to get this printer. And now we're going to be doing some mixed material development. And that we hope is going to take us to the next level.
And what does that next level look like to you over time? I know you mentioned you were going to do a fundraise to roll out and deploy and do all these things. What kind of number are you looking for there in the long run when you're ready?
In the long run, we're looking to raise about $20 million. We're not going to do it in one pass. We're going to do it in a series of tranches.
Yeah, absolutely. All right.
Yep. And so we've got that already figured out. We've got our pitch deck. We're willing to talk to people because we're reaching that point. In the manufacturing side, we're doing what we call America 2.0, as Mark Cuban said a few years ago during the pandemic, is that we build micro factories. So each of the factories has its own supply chain.
Sure.
And a lot of automation. A small group of people are able to build these satellites at an incredibly high rate, and then replicate that in 4 locations across the planet. So if anyone goes down, you're still producing satellites. Yeah, that really sets us apart. Is the whole business model is break things into the smaller chunks, work on the smaller chunks, and then build something incredible out of those pieces. And if you're building it right, you end up with a building. If not, you end up with Murphy's software law. Did you know that Murphy was a computer programmer?
Of course.
All right. Yes, Murphy's law of software development is if builders built buildings the way programmers write programs, the first woodpecker to come along would destroy civilization. So it's where else can you build we're gonna build the bedroom, we're gonna stick it here. All right, we'll put the kitchen underneath it later. Right. We got this thing called gravity. But in the software world, we don't have that. Well, we're doing the same thing with hardware and software. They're Lego pieces. And if we need a new Lego, we just invent the Lego we need. Or, well, this one isn't quite doing what we wanted. Well, okay, go make a different Lego that does the job.
Well, I think that kind of answers. So one of the questions in the chat is, first, he says, a lot of people would be surprised at how much tech can go into these things. But really the question is, how do you plan to utilize newer models or AI technologies to monitor ground systems? I think you kind of answered that. New systems are going to be new Legos, but could you go deeper into this?
Yeah, the software again is also modular, so we can actually update our models on the satellites as needed. Okay, that is not an easy process. I'm going to make it sound like, oh yeah, we're just going to type some code, we're going to send it up, and it's going to work. It's not like that. But we can update the models based on what the customer's needs are. So you build your models out with existing data. As we get more and more data, we can build better and better models. And so your models become self-reinforcing. And then you send those up to the satellite. And the satellite does the bulk of the initial pass. It's looking for the deep changes that we need to get to people. After that, we send the data down, and we can use AI to run through all of the materials that are down, all the data, and look for patterns that you wouldn't think about. We have a really good AI person working with us, and he's done some incredible things, things that even I thought weren't possible, but he's made it happen. And that's just amazing what he's been able to do. Find good people. And
find good people should be a T-shirt that every CEO, every president, every manager needs to have.
Here's the one thing I really do want to ask, though, because I have a little bit of experience in the satellite industry now. I work in it, and we, I mean, the standard ComSats that you see up there, they all have all these, KU, KA, C-band transponders and a lot of other frequencies, and all those things have to be space hardened so they can survive the first 30 minutes or so of their life. And of course, that adds mass to the thing, because you are, that thing, that space hardening is no longer necessary, but you're stuck with it for the rest of its operational existence. How are you getting around that problem? You're cramming a whole bunch of stuff into this tiny little sat. I keep thinking, how is that surviving the first 30 minutes of life?
Well, we learned the hard way that you have to think differently when it comes to these small satellites. Most satellites die because of overheating. Okay. We freeze to death. There's not enough thermal mass there. As far as the radiation.
Wait. Sorry, say that again. Most satellites die because of thermal heating, but you freeze to death because you're too small.
Right. Our entire systems run on 26 watts of power.
Wow. Okay.
There's not enough. There's not enough. Yeah. There's not enough power to put heaters in there.
Right. There's no heat. Okay. Yeah.
Right. So we have a system that, this is where I do the patent pending, that will allow us to move heat where we need it to without using heat pipes.
Okay.
By using that technique, and again, we're 3D printing. We get to make our own material. That's how we deal with the radiation of the low Earth environment, and I can't go into any other details than that, because that is like super proprietary.
Secret sauce. Secret sauce. All right.
Yeah, it's those things. It's not one thing that made this happen. I mean, I started this idea back in 2013, and the hardware was just not ready. Hardware wasn't even ready until 2018, but it wasn't possible to do what we're trying to do until the last 3 years.
Yeah.
And
yeah,
it just wasn't. And now we're seeing exponential change in the world, helped along by AI. But as these changes continue, it's like we just continue to iterate and update. And we found some materials that allow us to avoid some of the radiation issues. We have hardware that is designed to move heat around. Yeah, again, it's overused, but it's true. Cube is standing on the shoulders of giants, the people who came before us. They did a lot of work. They had a lot of blood, sweat, and tears to get where they were. And we look at what they did and honor them by continuing to develop further and further.
Well, I'm seeing here, Nick is asking, is it possible to update the satellite's code after it's already up there?
The answer is yes. Again, won't get into the specifics, but we can actually change the code. We can update the operating system as needed.
Very good. All right.
And then a similar question, can you use the same modules to build different spacecraft targeting other forms of space travel?
Actually, yes. Because everything is modular, we have a couple of things that we're working on. We do have, I'm going to put it back online. We had to take it offline for a little bit, but we have a lunar rover that we've developed, and it took us 2 weeks to build it using the existing tools that we had, because again, it's modular.
Right.
Yeah. Well, if you're going to do that, you need a lander. So we've been tinkering on with a micro lander.
Okay.
What would that look like? I'd rather just take a ride with somebody else. But if it turns out we can't do that, we can build it. We can build bigger satellites. Imagine this is going to be something that, again, I've got to, how do I explain this? Okay. Imagine that you had an engine that you're putting on a rocket. All right. You have to connect in a lot of plumbing to make that work, right? A lot of electronics. But what if it were a self-contained unit that you could bolt on? All right. So now I need to build like a hopper for the moon.
Mm-hmm.
I build in one single engine unit and replicate it. And then I connect it to the system by Wi-Fi.
Yep.
I only need power wires now. So we can build an entire spacecraft by snapping it together, because each piece is already built and designed and gone through all of those processes.
Mm-hmm.
You can put it together, do your qualification testing, do your acceptance testing, and be ready to fly. It allows us to build new things faster. Want to change these to be lunar spacecraft? Okay, we have to double the size because we need to go a little bit bigger due to the radiation environment, but make a few changes to the structure, but leave the building blocks alone.
Right.
Reprogram it, and you're good to go.
That's pretty neat.
Well, it seems to me, I was going to, it interests me because when you build them so small and so quickly and they're so light, it seems to me you could launch hundreds of these things in one shot towards, say, the moon or Mars, and actually jumpstart an entire communications network for a whole world at the same moment you're planting the first settlement there.
Yep. Yes. You got it. Instead of sending a big satellite that orbits the Mars, we send a dozen, and then we follow it up with another dozen and another dozen and another dozen, and you have them go enter orbit, make certain that they can adjust their orbits a little bit, but now you're getting science data or communications from multiple places instead of just one big massive machine.
Yeah, there's a lot to that.
That is a great way to end it. Joe Latrell at Cube, congratulations on getting the micro grant, and we hope to hear great things from you in the future.
Thank you much. I do appreciate it, and thank you for having me on the show.
Thanks a lot. Good luck.
Take care.
Take care.
Bye.
Okay, that was fun. That was amazing. It was a lot more than I thought it was when I first looked at this thing, and we all decided, oh, these are the guys that should win this month. It's well, a guy Nick is saying, what keeps the company from moving forward? It seems like a genius business plan. Well, it's always money. It's every time it's money. I mean, he's going to over time. He wants to raise another 20 mil. Well, he's on his way, and so. I mean, I kind of say half jokingly that, you were an unknown quantity before you came on the show, but now you're a known quantity when you leave it. That's our fervent hope for this program. Right. And so I hope we, in our own way, we helped him a lot. And it's always the money, always about the money. Okay, Michael, I'll see you.
Let's. On that note, I want to remind everybody, we do this this micro grant. We give $1,000 away every month to these startup ideas, and some of them are not much more than ideas scratched on napkin pads. Some of them have big teams with big plans, but we do give this money away every single month. So if anybody's interested in what we're doing and want to help out, There's a QR code up in the top left-hand corner. You can go to spacemicrogrants.com to make spacemicrofund.com to make a donation. We don't keep a nickel of that money. We pass it straight along to our to these grant winners. So thanks a lot, Joe. I'm going to sign off, sir. Thank you very much. And I will see you. Reminding everybody that we're going to a twice a week format. So I'll see you Tuesday.
Okay. Right. And as Michael just said, we're doing 2 shows a week now. Next Tuesday, March 11th, I'll be doing a remote cast from the Satellite 2025 conference in Washington, D.C., where we'll also be talking with our guest, Marcelo Bolt from the Space Generation Advisory Council. And we'll be talking about lots of ambitious plans for the Space Generation Congress in Sydney, Australia in late September, just prior to IAC. And so that should be a fun one. And we'll be doing a second show from the conference also on Thursday night next week. And so on that, from the news desk at the Center for Space Commerce and Finance, I'm Thomas Andrew Olson. Keep watching the skies.